NASA is working on dramatic new plans to extend the internet across our solar system and beyond. They're working with one of the fathers of the internet, Vint Cerf, in order to control and monitor spacecraft online in future, as he puts it, turning science fiction into science fact. Here's our technology correspondent, Benjamin Cohen.
The internet, so ubiquitous on Earth, is now challenging the final frontier.
We push you.
NASA astronaut Soichi Noguchi
Wow, he said it!
became a Twitter superstar during his stay on the International Space
He
Station.
has the chef hat.
But the internet in space isn't just being used for social media stunts. It's also being used to control unmanned craft, like those made here in Surrey. This is mission control at Surrey Satellite Technology, but it looks just like a regular office. That's because from here they're beaming the existing terrestrial internet into space to control 14 satellites currently orbiting the Earth. But the capability only extends so far because the internet that we all know relies on a constant connection, something that's just not possible once a spacecraft leaves the Earth's orbit. But that's now changing, with a new interplanetary internet system being developed. The man who invented the internet on Earth, now pioneering the internet in space.
It's very early days yet, but the protocols have become sufficiently robust that we believe they can be standardized soon, and that all spacefaring nations could use them in order to grow an interplanetary backbone in order to support both manned and robotic space exploration.
Satellites orbiting the Earth are close enough to maintain the constant internet connection needed for effective communications. But further into space, the more likely it becomes that objects such as planets and the Sun will break the connection. The new interplanetary internet system will relay the signal to spacecraft across the solar system in bite-sized chunks, speeding up the time it takes to send data back to Earth.
In the deep space environment, we have very long delays. You get to the outer planets, we're talking about delays of days. The interplanetary internet allows us to move the data around in an efficient way despite these long delays. That means more data, quicker data, and more accurate data.
But it's not just the solar system. Vint Cerf is leading US government-funded research looking at how this network could even be used to guide a probe to the nearest star, Alpha Centauri.
The next big step after doing interplanetary exploration is to consider sending a mission to the nearest star, which would be Alpha Centauri. In order to get there, we have to go a lot faster than we know how to do today. And we also have to be able to signal over 4 light years away, which is a really long distance, about 30 trillion miles. To do that, we're going to need a network of sensors that literally span the solar system and can pick up this weak signal that's coming back from a robot near Alpha Centauri. It's like everything else, engineering turning science fiction into reality.
Surrey Satellites will launch 7 craft connected to the new internet system this year, and the technology is already helping speed up communications to Mars as more spacecraft are reprogrammed. If all countries were to adopt this system, it could transform deep space communications, helping us understand our place in the universe.